Okay, YouTube, in this video we're going to quickly discuss the unit circle and how it is a nice tool to easily evaluate values of, say, cosine, sine, or tangent, or their reciprocals. And so let's go ahead and start by talking about what the unit circle is. We're going to start with this. It is a circle of radius 1. So a circle of radius 1 that's centered at the origin and is given by the equation x squared plus y squared equals 1. So that being said, we could say that with respect to filling in these values on the outside of the unit circle, the nice thing about it being a radius of 1 is that we can always say that if this is a circle of radius of 1, then we would say that this point here that is 1 unit to the right of the origin would be 1, 0. And likewise, we would say this is 0, 1. This would be negative 1, 0, and 0, negative 1. So with respect to the unit circle, we can always find those 4 quadrantal angles, x and y values, pretty quickly here. So now, the thing that makes the unit circle quite profound is essentially this. If we were to choose a point on the exterior here, we'll call this point just like x, y, and drop an altitude, we would say that given this angle theta then, this angle theta here, we could see that the sine of this angle, if we know that this is a unit circle, would have to be the opposite over the hypotenuse. But the thing that makes this profound is the fact that because we know this point x, y, we would know that the y value would be the height of this triangle and the x value would be the length here, the width. And we know that the radius is 1. So when we do the sine of this angle theta, what we really get is opposite over adjacent, or y over 1, or in other words, we just get y. And likewise, when we do the cosine of this angle, we get x over r, which our r value here is 1, so we get x over 1, and we just get x. So what we basically want to indicate here is that for the unit circle, and I would just kind of write this wherever you have room. I have room over here, so I'm going to write it over here, but we'd say all points x, y on the exterior of the unit circle. So we say all points x, y represent the cosine of our angle and the sine of our angle. And this is very true because when we did the sine of our angle, we got y over r, but with the radius of 1, we get y over 1. We really get y. Same thing with cosine. We say the cosine of our angle is x over r. Since our radius is 1, we'd say that it's x over 1. We really get x. So you can see that the x value here really is the cosine of that angle, and the y value really is the sine of that angle. So the profound thing about the unit circle is that it literally tells us both the cosine of the angle and the sine of the angle. So now, the last thing we want to make sure here that we mention is the tangent of the angle. And recall that the tangent of an angle is just y over x. So another way we could express this here is that it's the sine value of that angle divided by the cosine value of that angle, but we could just say just the y value over the x value. So what we want to do is come up with the values that run around the exterior of this unit circle. So what I'm actually going to start with is just kind of filling in some angle information. So let's start with our basic angles. We have 0 degrees is 0 radians. Also, pi radians is 180 degrees. How about up here at 90 degrees? So 90 degrees, that'd be a half of a pi rotation. So we say this is pi halves. And then down here, we'd have 3 90-degree rotations. So pi halves, 2 pi halves, 3 pi halves. This is 3 pi halves, or the same thing as 270 degrees. And so now that we've got our quadrantals up here, I'm always a big fan of now going for our half of a 90-degree angle, or 45s. If we go in increments of 45s, it's pretty easy to see that you could fit 4 45-degree angles into a full 180 degrees, or a full pi rotation. So what we're really looking at here is that a 45 is really a fourth of a pi rotation. So we'd have a fourth of a pi, 2 pi fourths, same as pi halves, 3 pi fourths would be here, 3 pi fourths, okay, would be the same as 135 degrees, 4 pi fourths, or 180 degrees, 5 pi fourths here, so 5 fourths of pi, this would be the same as 225 degrees, we have 6 pi fourths, which is the same as 3 pi halves, 7 pi fourths, we're going to go our 7 pi fourths here, and then that would be the same as 315 degrees, and then we would say 8 pi fourths would bring us all the way around. 8 pi fourths would be the same as 360 degrees, or 2 pi radians. And so, now that we've got those down, just remember that every fourth of a pi is really a fourth of 180, and so you're dealing with 45s. For the rest of these angles, what I'm going to start with is my third of a pi rotation. So now thinking about a third of a pi, it's a third of 180. We have every third of a pi is a 60-degree rotation. So we say this is our 1 pi third right here, which is the same as a 60-degree rotation. But 2 60s, which would make 120, which lies right here, that would just be 2 pi thirds. 3 pi thirds, which is pi, is the same as 3 60s is 180. 4 60s is 240 degrees, but also suppose we would say that we have 4 of these thirds of pi. 5 of these thirds of pi is just right over here, so 5 thirds of pi, which is our 300-degree angle. And then we have 6 thirds of pi, which is 2 pi. And then our last angle increments here, we're going to go around in 30s, multiples of 30. And remember, 30 degrees is a sixth of a pi rotation. So a sixth of a pi rotation. So we have 1 pi sixth, another 30, which is at 60 here now. That's 2 pi 6, but you notice we already have this. So another 30 is 3 pi 6, another 30 is 4 pi 6, another 30 is 5 pi 6. We have 5 pi 6, which is the same as 150 degrees, or 30 short of 180, a pi 6 short. This is a pi 6 past 6 pi 6. We have 7 pi 6. 7 pi 6 is a 210 degree angle. And then over here we're going to have 11 pi 6, which is a pi 6 short of 2 pi, or pi 6 short of 12 pi 6. So with this here, what we're going to do now is we're basically going to go and fill in all of the x and y information for all these ordered pairs. So one thing that's really neat about this is that there does exist a pattern, and it's simply that our sine and cosine values, or I should say cosine and sine values respectively, are all over 2 for these 3 special angles here for our special right triangles, 30, 45, and 60. And the way we construct the rest of this is with your x values, you just count down. You just say 1, 2, 3. And you can put a root 1 over here. It's just that I put a positive 1 and not a positive root 1 because I guess they mean the same thing. Going excuse me, back up the right side, we're just going to say it's reversed. So we have 1, 2, 3. And the neat thing about this is because excuse me, the trig function of an angle, say a 60-degree angle here, okay, so here's our 60, and the trig function of another angle that is not 60, maybe 120 degrees, but has a 60-degree reference angle, these two sets of ordered pairs here are going to have the same values because they construct the same triangle. So the neat thing about it is we really only need to know the first quadrant values because that'll allow us to go and fill in the rest of the quadrants because of symmetry. So for instance here, this 120 has a 60-degree reference angle, so this has to be 1 over 2 like our 60 had 1 over 2. And this must be root 3 over 2, and that's a root 3 over 2. So we get a negative x value is the only difference between these two here. So I'm going to go ahead and fill in the rest of these. The neat thing is that they're all over 2. So I can go ahead and do this now. 2, 2, 2, 2, 2, 2. I'll let you go ahead and do yours there. We say 2, 2, 2. We'll fill these in using symmetry. Because this was the 1 here, I know that this is the 2 and this is the 3. And because that's a 3, this is a 1, this is a 2, and 2, not a 3, and this is the 3, and all of our x values are negative. Likewise down here, I know that this and this have to be the same. So this is a root 3 over 2, and this is a 1 over 2, but they're both negative. X's and y's are both negative down here. So this must be root 2, this must be 1. So this must be root 3, this must be root 2, and these are all negative down here. And then likewise, we could go over to our fourth quadrant. We say that, well, then this one right here have to be the same as this one right here because they both have a 60-degree reference angle. Then we would have a 1 here and a 3 here. And our y value would be the negative 1 this time. So if that's a 1, this is a 2, this is a 3, this is a 1, this is a 2, and all of our y values are negative here. So now that we've constructed this tool, basically what we're going to do is use that to evaluate some trig function values. So for instance, cosine of 120, the way this works is that the x value of that angle is the cosine of that angle. So we would say at 120 degrees, 2 pi thirds radians, we say that the x value here really represents our cosine. So we say the cosine of 120 degrees is really just negative a half. Same thing with sine of 330. We say 330 is all the way down here. What's our sine value? It's just a half. And it'd be a negative a half as a matter of fact. So we get a negative a half here. So now looking at a tangent value of 225, interesting thing is that 225 is right here. And so with respect to tangent, remember that tangent is y over x. And so our tangent of 225, I'm going to write that down here, 225, is really the same thing as our sine value at 225, which is the y value here, negative y, y over x. We get negative root 2 over 2 over x, which is also a negative root 2 over 2 down here at this 225. So dividing something by itself, we just get 1. And honestly, the tangent of 225 really is just 1. I'm going to write that 1 there. So I want to look at really quickly here just a couple more. How about a reciprocal trig function? So this would be something like maybe a cosecant here. We have cosecant of 5 pi 6. So with respect to cosecant of 5 pi 6, the very first thing we want to acknowledge is that this is the reciprocal of the sine function. So we have the cosecant of 5 pi 6 is the same as 1 over the sine of the same angle, 5 pi 6. And so what we need to do is go find the sine of 5 pi 6. Now using the unit circle again, the sine of 5 pi 6 is the y value here. So we get a half, and it's a positive a half. So all I'm going to do is I'm going to go back up here, I'm going to substitute in for my sine of 5 pi 6, I'm going to put in a half. And 1 divided by a half is just the reciprocal of a half. Looks like we get a positive 2. So that's what it's going to look like with a reciprocal function. Let's also take a look at an instance, I suppose, where we have a reciprocal function in a quadrantal angle. So this would be something like this. So again, cosecant, we're going to have to do the reciprocal of sine, 1 over the sine of pi. And the sine of pi, we can just go over here and look at our unit circle. Because it has a radius of 1, at pi radians here, right there, boom. We know that our y value is 0. So really what we end up with here is 1 over 0, which is undefined. So use your unit circle. I want everybody to find the rest of these and see what you come up with using this tool. Cheers.